All right, let's talk about something that's, well, basically running the world behind the scenes. Functions. Now, don't let that word scare you. They're really just the hidden rules that make everything predictable. And trust me, by the end of this, you're going to start seeing them absolutely everywhere.
So to get our brains warmed up, I've got a question for you. As we look at these next few images, just ask yourself, what's the rule? What's the relationship that connects these things?
Okay, first up, a person's weight and their body mass index, or BMI. You've probably heard of it, right? Well, there's a very specific mathematical rule that takes your weight and height as inputs and gives you one single BMI number as the output.
Or how about a coffee shop menu? You know the deal. Each item, a plain donut, a jelly donut, is tied to exactly one price. You pick the item, you know the cost. It's a super clear, totally predictable relationship.
And it's not just for real-world stuff. Check out this graph. Every single point you could possibly pick on that bottom line, the x-axis, lines up with exactly 1 point on that blue curve. It's not random at all. It's following a consistent rule. And that rule, my friends, is what a function is all about.
So how do we wrap our heads around all this? Well, the best way I know how is to think of a function as a perfect little machine, an input-output machine.
Seriously, it's just like a vending machine. You press button B3, that's your input, and you get a bag of chips every single time. You always know what you're going to get. Now, if you pressed B3 and sometimes you got chips and other times you got pretzels, well, that machine would be broken, right? Functions are the machines that work perfectly.
And this slide, it shows this perfectly. See on the left? That's our working machine. Every input, P, Q, and R, has exactly one arrow leaving it, pointing to one output. It's okay that P and R both point to Y, no problem. But look at the machine on the right, total chaos. That input Q is trying to go to two different places, Y and Z. That's not predictable. That is a broken machine, and it is not a function.
Okay, so the machine analogy is clicking. Now let's put on our fancy math hats for just a second and learn the official lingo. I promise it's just a more precise way of saying the exact same thing we've been talking about. So first up, there's this big umbrella term called a relation. A relation is, well, it's pretty much any connection between two groups of things. Remember that broken machine? That's still a relation. It describes a relationship, even if it's a messy one. But a function is a special kind of relation. It's the VIP. It's more reliable, more predictable, because it follows one simple, absolutely crucial rule.
And here it is. This is it. The single most important sentence in this entire explainer, the golden rule. If you walk away with just one thing today, let it be this. For each input, there is exactly one output. Burn that into your brain. That's the heart and soul of what a function is.
Okay, just a couple more vocab words, and they're super easy. The domain is just the fancy official name for all the stuff you're allowed to feed into the machine. It's the whole menu of possible inputs.
And if the domain is what goes in, you guessed it, the range is everything that can possibly come out. It's the complete set of all the possible results your machine can spit out. Simple as that.
So how do we actually write these rules down without drawing a whole machine every time? Well, mathematicians came up with a really clever shorthand called function notation. And I know, it might look like scary algebra at first, but trust me, it's just a way to pack a ton of information into a tiny little space.
This is what you'll usually see. It's read y equals f of x. Let's break that down real quick. The x in the parentheses, that's your input. The f is just the name of the function, like a nickname for our rule. And the whole chunk, f of x, just means the output you get when you plug x into the rule f. So all this really says is that your output, y, depends on what your input, x, is.
Let's try one out for real. So here's a function we're naming f. Its rule is simple. Take whatever the input x is, multiply it by 2, and then subtract 5. So if we want to find f of 4, we just replace every single x we see with a 4. So 2 times 4 is 8, and 8 minus 5 is 3. Pop in a 4, get out a 3. See? Not so bad?
All right, so functions are always going to be handed to you in that neat f of x package. Sometimes they're in disguise. They can show up in a few different forms, but as long as they follow that golden rule, one input, one output, they're still functions. For example, you might see a table of values, like this one. So how do we know if it's a function? We just check our rule. Does the input 2 go to only one place? Yep, to 1. Does 5 go to only one place? Yep, to 3. Same for 8. Every input has exactly one output, so this table represents a function.
Or check out this visual way of showing it, a mapping diagram. The arrows literally show you where each input goes. We can see that 5 points to 3, 9 points to 5, and 0 points to 9. See how every number on the left has just one arrow pointing away from it? That's the sign of a function, folks.
And then there's the big one, graphs. A graph is awesome because it gives you a picture of the function's entire rule all at once. For any x value you pick along the bottom, the graph shows you the one single y value that it matches up with on the side.
But wait, how can you tell if some random squiggly line on a page is a function just by looking at it? Well, there is an amazing, super simple trick for this. It's called the vertical line test, and it's kind of like a math superpower. Here's all you do. Imagine a perfectly straight, vertical line, like a pencil. Now slide that line across the graph, from left to right. If your line only ever touches the curve in one spot at any given time, bam, it passes. It's a function. Why? Because it proves that for every x value, there's only one y value. But now, look at this circle. We take our vertical line, and whoa, it hits the graph in 2 places at once. That's a huge red flag. It means one input, x, is trying to have 2 different outputs, y. That breaks our golden rule. So this graph fails the test. It's a relation for sure, but it is not a function. So there you have it. Whether it's a graph, a table, or that f of x thing, it all comes back to that one golden rule. Functions are all about predictability. They describe any relationship where one action reliably leads to one result, from the price of your coffee to the speed of your car. So I'll leave you with this. Think about it. What's one function you'll interact with before the day is over?